Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 16 video from the chapter of Herons Formula, I will be solving another 5 practice problems. This is set 2 based on the full concept based on the concepts of the entire chapter of Herons Formula. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so these 5 concepts, the problems that I am solving as revision of chapter concepts will be the most important ones, and based on these are conceptual problems. Okay, the first question says the perimeter of a right triangle is p centimeter and its area is a centimeter square. Then the sum of the lengths of the perpendicular sides in centimeter is. Then the sum of the lengths of the perpendicular sides in a centimeter is. Okay, so let's say this is the right angle triangle, and let's say the perpendicular length of the perpendicular sides are let's say x and y. Now, so what will the area is given as a centimeter square. So we know area will be, considering the perpendicular sides as base and height, this will be half into x into y, that is xy by 2. From here we can say that xy, the product of the length of the perpendicular sides, will be twice a. Okay, the perimeter is given as p centimeter. We have to find the sum of the lengths of the perpendicular. Okay, so let's say we have to find the value of x plus y. Let's say we are calling this as z, just for the sake of easiness of solving the problem. Instead of writing x plus y all the time, I am giving a name to x plus y variable, to the value x plus y, which is z. Okay, now since this is a right angle triangle, the hypotenuse, what will be the hypotenuse? The perimeter is already given, so obviously the hypotenuse has to be p minus of x plus y. This is equal to p minus z, because we have assumed the value of x plus y to be z. Okay, now also this is a right angle triangle. Using Pythagoras theorem, we can say that the square of the hypotenuse, square of the length of the hypotenuse, which is p minus z whole square, should be equal to the sum of the squares of the perpendicular sides, which is x square plus y square. Now the concept, the idea is that you have to be a little smart in working with algebraic expressions or identities and formulas. I have to find the value of z, so I have to create an equation so that from where I can find the value of z. On the left hand side I can see it is p minus z, that is fine, but on the right hand side I see x square plus y square. I have to somehow convert the right hand side in terms of z, p and a. Now one way is that so x square plus y square is I know x plus y whole square minus twice xy. X plus y we know is z, so this is z square minus 2 into xy, we have already found to be twice a. So now you will see the right hand side is in terms of z, a and p, even though we do not have p, but still we have found an equation. So this implies, what do we get? If I expand the p minus z whole square on the left hand side, it is p square plus z square minus twice pz is equal to z square minus 4a. Z square will cancel out from both the sides, and then we can easily see that this becomes a linear equation in z, from where we can easily find the value of z. So I have twice pz is equal to p square plus 4a. So this implies z is equal to p square plus 4a divided by twice p. So the value of the sum of the lengths of the perpendicular sides which I have assumed to be z x plus y is p square plus 4a divided by twice p. So the correct choice is C is the correct choice. Now, as I always say, if I am doing any kind of calculation mistake, silly mistake, and solving the problem incorrectly, or I am applying concept incorrectly, or I am applying incorrect concepts, in all these cases, please feel free to let me know in the comment section. I will highly appreciate that. And if you have any doubt at any steps regarding any concept, why I am applying, or if you have any question in general about a particular concept of any chapter of a particular chapter, then please feel free to let me know in the comment section. I will do my best to address your query and doubt. Let's see the next question. Question number 2. ABCDEF is a regular hexagon where AB is equal to x. Then the area of the triangle ABD is. Okay. Now, one thing you must be you must know some properties of a regular hexagon. There are a lot of good properties you must know for a regular hexagon. Once you know all those properties, then you can apply those properties and solve the problems based on regular hexagon. So let's say 1, 2, 3, 4, 5, 6. This is a regular hexagon. Okay. First thing is that we have the center of a regular hexagon, not regular hexagon, it could be any regular polygon. The center of any regular polygon is the point of intersection of all the perpendicular bisectors of the sides. If you draw the perpendicular bisectors, okay, let's say this is the regular hexagon A, B, C, D, E, F. I am drawing the perpendicular bisector of the side AF. So let's say this is the midpoint of the side AF. Then passing this midpoint, I will draw a line perpendicular to AF. So if I draw this perpendicular line, so this is a line. This is the perpendicular. This line, let's say this is L. Let's say this is L. So this is the perpendicular bisector of the side AF. Similarly, all the perpendicular bisectors of all the sides, they will intersect at this point O, which is the center, which is known as the center of the of a regular polygon. Now, okay. Now specifically for a regular hexagon, if you join this center O with all the vertices, if you join all the vertices, will form equilateral triangles with the center of the regular hexagon. So you can see this is an equilateral triangle A. So this is an equilateral triangle AOF, FOE, EOD, DOC and COB. These are all congruent equilateral triangles because the length of all these equilateral triangles is equal to x. That is the length of the side of the regular hexagon. So this entire regular hexagon has been divided into 6 congruent equilateral triangles. So the area of the regular hexagon is equal to 6 times the area of one such equilateral triangle. Let's say it could be triangle AOF or FOE. Now this perpendicular, let's say the perpendicular bisector of the side AF is intersecting the side AF at the point T. So OT is the altitude of the equilateral triangle AOF, and we know, and the equilateral triangles, all these equilateral triangles are having a side length of x. So the length of OT will be from the formula of the altitude of an equilateral triangle, it is square root of 3 divided by 2 x. Okay, and so what will be, again let's say this line, the perpendicular bisector of the side AF is also is passing through the origin O, and let's say it is intersecting. So it will also be the perpendicular bisector of the side CD. Let's say it is intersecting the side CD at U. So obviously we will have OT equals to square root of 3 by 2x. This is also equal to OU. And of course TOU are collinear. So okay, now so OT, OT, so these are small results and observations I am discussing. TO plus OU will be equal to twice OT. This is equal to square root of 3 into x. So the length the length of the perpendicular bisector of two, you can consider AF and CD to be opposite sides. So the length of the perpendicular bisector of the opposite sides AF and CD, which is TU, is equal to square root of 3 multiplied by x, where x is the length of each side of the regular hexagon. Also you will see that we will have AO will be equal to OD. AO will be equal to OD, and of course this is equal to x because AO is also one side of the equilateral triangles. So AD will be equal to twice AO, which is equal to twice x. AD is equal to twice x. Now the reason I have discussed about AD is that in the given problem you see AD. So if you know in the regular hexagon, in the given problem the side length of the regular hexagon is given to be x, so I can clearly get that the length of the side AD will be x. Now whether it is required to solve the problem or not, that is a different topic. I am just trying to give you some results of a regular hexagon and properties. So AD will be equal to, that is AD will be equal to twice x. This will be equal to CF. This will also be equal to BE. Yes, so AD is equal to BE is equal to CF. And also I couldn't draw the sides of the equilateral triangle properly. BOE will be collinear, TOE will be collinear, AOD will be collinear, COF will be collinear. Okay. Now one more thing is that the internal angles, all the internal angles of a regular hexagon is 120 degree. So angle BAF is equal to 120 degree, and also so we can say BAF is 120 degree. Okay. Now let's say in this regular hexagon 120 degree and okay, and also I know this is the one angle of an equilateral triangle. This is 60 degree. Okay, so this will also be 60 degree. This is 60 degree. Now please note that we will also have BC will be parallel to AD. BC will be parallel to AD. So you can see a lot. So BCDA will be a trapezium. Similarly, CF or COF will be parallel to DE. Now in the problem, let's consider the problem. So we have to find the area of the triangle ABD. I know the thing is that the triangle ABD, the angle ABD, this will be 90 degree. This is what I am trying to derive. This angle ABD will be 90 degree. So once we have found that angle ABD is 90 degree, then using the formula half into base into height, we can clearly find the area of the triangle ABD, because it will be half into x into BD. But we have to find BD. We have to find BD. We have to find BD. Okay. Now what BD? Okay. How will we find BD? mm, BD, also note that BD, if you join B and D, if we join in this regular hexagon BD will be equal to twice the length of BD will be equal to TU. BD will be equal to TU. TU was twice the length of the altitude of one equilateral triangle. So BD will also be, so if you join BD, then BD will also be the perpendicular, will be if let's say BD intersects CO at the point, let's say V, then BV will also be an altitude of the equilateral triangle BOC, and VD will also be the altitude of the equilateral triangle COD. So then BD will be equal to TU, which is equal to twice BV, and this is equal to BV is nothing but the altitude of all the 6 equilateral triangles, which is square root of 3 multiplied by 2 into x. So this is square root of 3 into x. So you see BD is also equal to TU, which is square root of 3 into x. So we know BD is equal to square root of 3 into x. Now, and we know x, we know AB. So obviously the area of the triangle ABD, once we prove that angle ABD is the right angle triangle, right angled at B, we can say the area will be half AB multiplied by BD. This is equal to x, AB is x, BD is square root of 3 into x divided by 2. This is equal to square root of 3 divided by 2 x square. This will be the answer, area. Now let me quickly discuss why in the triangle ABD angle B will be 90 degree. Now you see BC, so we have proved that you can, as a property, I mean I will not discuss about the proof, I will not prove anything, but please note that BCDA is a trapezium, as BC will be parallel to AD, and also in this trapezium the two non-parallel sides are equal, that is AB and CD are equal. AB is equal to CD because they are the sides of the regular hexagon. So this is an isosceles trapezium. ABCD is an isosceles trapezium, and this angle will be equal to this angle. And also you see that in this isosceles trapezium BD is a diagonal. BD is a diagonal. The two diagonals in an isosceles trapezium bisects the base angles. That is, in this isosceles trapezium BCDA, the diagonal BD will bisect the angle CAD and BAC. So this angle will be equal to this angle. Now we have already seen that angle BAD is equal to 60 degree. So this will imply that angle BDA will be equal to 60 degree divided by 2, which is 30 degree. Angle BDA is 30 degree. Angle BDA is 30 degree, so this is 30 degree. And this is 60 degree. BAD is 60 degree, so obviously angle B will be 90 degree. So angle ABD will be a right angle triangle. Always remember these small observations. These are important, very important properties you must know. So then the area of the triangle ABD will be half into AB the perpendicular we can consider is the altitude we can consider as AB and the base as BD. BD we have already found to be square root of 3 into x. So the area is square root of 3 by 2 into x square. So the correct choice is D. This is a very very important important question. Always please note all the properties of the regular hexagon that I have discussed so far. It will be useful to know to find to solve this problem, and also to find the length of the diagonals, that is the length of AD, or the length of the perpendicular bisectors of two opposite sides, that is in the second figure the length of TU. Basically T O U are collinear. O is the center of the regular hexagon. The length of TU will be equal to twice the length of the altitude of one equilateral triangle. There are 6 equilateral triangles formed in this regular hexagon by all the sides with the center O. So all these concepts you must note and remember. Okay, let's see the next problem. A parallelogram has two of its adjacent sides measuring d centimeter. Find the sum of the squares of the diagonals. A parallelogram has two of its adjacent sides measuring d centimeter. Okay, so let's say these are the two adjacent sides. This is d, length d, and this is length d. Okay, so let's say this be the parallelogram AB, C, D. Now this is a parallelogram. ABCD is a parallelogram. So obviously we must have AB is equal to DC, and we will also have AD is equal to BC. Now we know that AD is equal to DC. This will imply that AB will be equal to AB we know is equal to DC from the properties of a parallelogram. The opposite parallel sides of a parallelogram are equal in length. So AB is equal to DC, this is equal to AD, this is equal to D. So we can also see AB is D, and obviously also BC will be equal to AD is equal to D. So we see all length of all the sides of the parallelogram are equal and of length d centimeter. Now in a parallelogram, if all the sides are equal, then it must be a rhombus. This is the concept. This is the catch of this problem. If in a parallelogram all the sides are equal, then it must be a rhombus. Okay, so definitely in a rhombus we know the diagonals bisect each other at right angles. Okay, now so we know, so this is a rhombus. We know the length of each side of the rhombus as a d. Now you must know the concept that if you know so what is the relation between the length of the two diagonals of a rhombus and the length of each side? If AC is equal to, that is the length of the diagonal AC is equal to d1, and the length of the diagonal BD is equal to d2, then you must always remember this formula that the square of the length of each side d square will be equal to the sum of the squares of the diagonals d1 square plus d2 square divided by 4. Now how this is coming? This is coming from the Pythagoras theorem. Let's say the diagonals intersect at the point O. So what is AO? AO is AC by 2. Since the two diagonals bisect each other at the point O, AO will be AC by 2, and AC is D1, so D1 by 2. And what will be OB? OB will be equal to BD by 2, which is equal to D2 by 2. Now applying Pythagoras theorem in triangle AOB, AB square is equal to AO square plus OB square. This implies AB is D, so D square is equal to, what is AO? AO is D1 by 2 square plus D2 by 2 square. this will, if you simplify the right hand side, it will be d1 square plus d2 square by 4. This formula you must always be remembering. It must always be in your head all the time. That is, in a rhombus, the square of the length of each side is equal to the sum of the squares of the length of the diagonals whole divided by 4. So now from here we can clearly say then d1 square plus d2 square is equal to 4 times d square. This is what the question has asked. Find the sum of the squares of the diagonals. So the sum of the squares of the diagonals will be equal to 4d square. So the correct choice is D. D is the correct choice. Let's see the next question. Question number 4. The lengths of the diagonals of a rhombus are d1 and d2 centimeter. Find the distance between any two parallel sides of the rhombus. So let's say this is the rhombus. It's not looking like a rhombus. Anyway, let's consider this to be a rhombus AB, C, D. So the diagonals are AC and BD. AC and BD. Let's say the length of AC is D1 and the length of BD is D2. Okay. Find the distance between any two parallel sides of the rhombus. And also we know that from the length of the diagonals of a rhombus we can easily find the length of each side of the rhombus. So if the length of each side of the rhombus is A, then we know from the previous problem we have A square is equal to D1 square plus D2 square by 4. This implies A is equal to square root of D1 square plus D2 square by 2. Okay. Now we have to find the, now rhombus is a parallelogram. So what is the, now what will be the area of this, Now the question has asked to find the distance between any two parallel sides of the rhombus. So we know that in a parallelogram the area of a parallelogram is equal to the length of one opposite parallel sides and the distance between them. So when the question has asked to find the distance between any two parallel sides, the idea of finding the area of a parallelogram should immediately come into your mind. So let's say, so the distance between, if you consider any two parallel sides, we have two pairs of parallel sides in a rhombus or in a parallelogram. So the distance between any two parallel sides will be same in a rhombus. Please note that, not in a parallelogram. In a parallelogram, the distance between let's say this is a parallelogram. So the distance between let's say these two sides, the distance between these two parallel sides, let's say this perpendicular distance is this, and the distance between these two parallel sides is let's say this. So this will be different. In general, the distances between the two opposite parallel sides are different in a parallelogram, but in rhombus they are same. That is why the question was asked to find the distance between any two parallel sides. It will be same. Okay. Now the area of the rhombus, will be based on the formula of area of a rhombus is half. We know it is half and half multiplied by the product of the diagonals. So D1 multiplied by D2, that is D1 into D2 divided by 2 is the area of the rhombus based on the formula of area of a rhombus. Now the rhombus is also a parallelogram. So applying the formula of area of a parallelogram, the area of the rhombus will be the area of a parallelogram is the product of the base that is the length of one parallel side and the distance between the distance between two opposite parallel sides, not two, a pair of opposite parallel sides. So the area of a parallelogram is product of product of, if you consider one side or one base, and then product of the base and the perpendicular distance of the opposite parallel side of the base. So we can consider, so in that, from that formula, applying the formula of area of a parallelogram, the area of the rhombus will be, I can say, half A multiplied by h, where h is the perpendicular distance between any two parallel sides. So this implies, I can say that d1 into d2 by 2 should be equal to ah by 2. 2 cancels out. So this, from here we can say h, that is the distance between the two parallel sides of the rhombus, will be equal to d1 into d2 by a, and a we already know is equal to square root of d1 square by d2 square whole divided by 2. So this becomes twice d1 into d2 divided by square root of d1 square plus d2 square. So this is the distance between any two parallel sides of the rhombus, where d1 and d2 are the lengths of the diagonals of the rhombus. So the correct choice is D. T is the correct choice. This is also a very conceptual problem. Question number 5. ABCD is a parallelogram and ADB is an equilateral triangle. If BD is equal to y centimeter, then area of the parallelogram ABCD and length of diagonal AC are. Okay. This question is very similar, not very similar, similar to this problem, question number 3. Eventually, the result that we have to identify are same. So it is given ABCD is a parallelogram. Fine. Okay. So this is parallel to this. This is parallel to AB, and AD is parallel to BC, and of course DC is equal to AB and AD is equal to BC. Okay. Now ADB is an equilateral triangle, which means this is 60 degree, and also so BD is given to be y centimeter. So the length of the diagonal BD is given to be y centimeter, and since ADB is an equilateral triangle, we will have BD is equal to AD is equal to AB. They will be all equal to y centimeter, and this is 60 degree, this is 60 degree. So AD is also y and AB is also y. This will mean that DC is also y. So this will imply that DC is also equal to y and BC is equal to y. So we clearly see that the length of all the sides of the parallelogram are equal, and the length is y centimeter. So clearly we can see that ABCD is a rhombus. If in a parallelogram all the sides are equal, then it must be a rhombus. And we know that and we know that clearly we can see that the length of one diagonal BD is given to be y centimeter. Okay. Now we are asked to find the area of the parallelogram and the length of the diagonal AC. Okay. Now, so we also know that since this is a rhombus, the diagonal BD, any diagonal of a rhombus divides the entire rhombus into two congruent triangles. So if you have any rhombus, sorry, what is this? Let's say this is a rhombus. Sorry. Let's say this is a rhombus. So, okay. My rhombus is not looking perfectly anyway. So if I this diagonal will this diagonal, so let's say the rhombus is P Q R S. So we will have the diagonal QS is dividing the entire rhombus into two congruent triangles PQR. These are congruent triangles RQS. Also, if you consider the diagonal PR, then also the diagonal PR will also divide the rhombus into two congruent triangles. We will have P what I did, sorry, in the for the diagonal QS, the triangle PQS will be congruent to triangle RQS, and considering the diagonal PR, we will have triangle PQR will be congruent to triangle PSR. So congruent triangles, the areas are equal. So we can say that in this problem, in this parallelogram, basically it is a rhombus. I can say then the area of the parallelogram ABCD will be equal to 2 times the area of the triangle ABD. Both ABD and BDC are equilateral triangles. Since we can clearly see that in the triangle ABD all the sides are equal y, and also in the triangle BDC all the sides are equal, which is equal to y centimeter. Okay. Now ABD is an equilateral triangle having length of each side as y centimeter. So the area of the triangle ABD will be square root of 3 divided by 4 y square. This is equal to square root of 3 divided by 2 y square. So the area of the parallelogram is square root of 3 divided by 2 y square. From this, from here at this point only, I can say the correct choice is D, because in no other choices the area is given as square root of 3 divided by 2 y square. So obviously the correct choice is D, but let's find out what will be AC. How do we find the length of the diagonal AC? We know the area, we know that the this is a rhombus. This is a rhombus. Based on the area of a rhombus, we know the area, let's say this be the area capital A. So area will also be equal to half the product of the diagonals, that is BD multiplied by AC. AC is given to be y, so this is y by 2 multiplied by BD, and this is equal to A, which we know is square root of 3 by 2 y square. So we get the equation rather, y by 2 into BD is equal to square root of 3 by 2 y square. 2 cancels out from both the side. I can also cancel y. Okay, so this implies BD will be equal to so BD will be equal to then square root of 3 y square by y. This is equal to square root of 3 into y. So the length AC, it will be AC. The BD was given, I'm sorry, over here this will be we already know BD, so this will be not BD, but this will be AC. Okay, so this is AC. So AC is equal to square root of 3 multiplied by y. So the area is square root of 3 divided by 2 y square, and the diagonal length of the diagonal AC is square root of 3 into y. So this is also a very conceptual problem. So that is all for the 5 conceptual problems of set 2. Probably I will make 2 or 3 more videos that is two or three more sets of 5 problems each, 5 conceptual problems. Please do not miss these videos. I will be solving really good problems, so please stay tuned. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.